Let's take a trip inside and just have you point out some of the features of the chamber and some of the equipment.
Sure.
All right, so we're inside, Matt, and the first thing I'm going to say is, wow, it's quiet in here.
Yeah, it is.
Yeah, so there's really no echo, so it's notable. But tell us a little bit about what you've got in here and what we're doing.
Sure. So to begin with, the anechoic part of this, you mentioned that we've got no echo, audible echo. But really what we're looking for in this chamber is higher frequency echo. So everything on the walls that you see around us is here to absorb EMI. Okay, so it will absorb radio waves. The entire chamber, or room as we want to call it, the walls and the ceiling are completely covered with ferrite tiles. This is exactly the tile that's in there, and
whoa, that's heavy.
Yeah.
Yeah. Wow.
It absorbs the lower frequencies of the radiation. These are effective typically in the range of 10 megahertz up to maybe a couple hundred megahertz. And then what we do is put these foam wedges on top of that. These foam wedges will work in the range of, you know, a couple hundred megahertz up into the 20, 30 gigahertz range.
Okay, so we're that high up.
Yes.
Okay.
Yes.
Okay.
And the shape of the wedges is such that, right, the lower frequencies are absorbed by the wider part, and as it gets narrower out here, the higher frequencies are absorbed. Very
interesting. What do you got going on behind here? What you doing, Matt?
So this is a typical layout of how we would be doing some EMC testing in here. We've got a server here. We've got power lines that run across the table, and they're off of the top of the table. Our tabletop is made of copper. Most of the testing we do requires what they call a ground plane, which is a tabletop, and all of our cables that come off the equipment need to be suspended above that copper.
And I know this is a LISN here, right?
Correct.
What does a LISN do exactly?
So LISN is a line impedance stabilization network, and what it does is it gives us a standard impedance of our power lines for running our tests. Now, does the LISN actually look like an aircraft power line? No. The standards that we test to have come up with certain frequency, certain impedance curves of what they want that to look like, so that we can get repeatability in our testing.
So it's almost like kind of a baseline, so that then you can compare?
Correct. Okay. So when we go, you know, if we test here and we test with that LISN, we can go to any other test lab and test with their these are MIL 461 LISNs. We can test with their MIL 461 LISNs, and we know that we're testing against the same impedance.
Okay, so they're calibrated.
That's correct.
Okay.
Yes.
Okay, perfect. So Matt, tell me about this contraption. This kind of looks like a TV antenna.
Well, you're right, it's an antenna. This is called an X-wing bi-log antenna. So it actually has multiple elements to it. You can see the elements here. They start very small in the front. They get larger as it goes to the back. That's the log periodic part of the antenna. The large X-wings on the back, that is the biconical part of the antenna. And if you look right behind you here, this is actually a full biconical antenna. So this antenna here, the one that's in yellow, is used for susceptibility testing. So what we would do is we would hook an amplifier onto this guy. We send noise out of here and bombard.
So you're bombarding the unit and
Correct.
seeing if it's susceptible to those emissions.
Correct.
Okay.
The other antenna here behind you is what we would use for emissions testing. So it would be in the neighborhood of 100 megahertz up to probably around 500 megahertz, somewhere in that range.
Okay, all right. And what's with the mast here? What happens with that?
All right, so the mast, there is some testing that requires the antenna to be raised and lowered with respect to the equipment that's under test. And so this mast would allow us to do that while we're not in this chamber, because when you're sending out EM from an antenna, you really don't want to be in that area. So this is remotely controlled. We can control it from our lab bench, which is right outside the chamber here.
Okay. I also noticed there's a rotating section of the floor that allows you to spin a unit or something?
Correct. Some of the testing, well, actually most of our testing, requires us to place the unit under test in the orientation that would emit the most noise. And so what the turntable does for us is it lets us put a piece of equipment on there, and then we can run a test while it's rotating. From that we can find out which orientation has the highest emissions. Then we will set it on our bench in that orientation and run our testing.
Okay.